This video is for Chemistry in the Earth System, Unit 2.1. Today's essential question: what is the difference between atomic mass and atomic number? First main idea: atomic mass versus atomic number. The atomic number of an element equals the number of protons in the nucleus of its atoms. The atomic number is the same for every atom of a particular element. For example, the atomic number of hydrogen and all its isotopes is 1. The mass number will vary for different isotopes of the same element because different numbers of neutrons are present in the atoms. Mass number is usually used to describe a specific isotope that a scientist is working with in a lab. The isotopes of hydrogen have mass numbers of 1 and 2 for hydrogen 1 and hydrogen 2, respectively.
In the periodic table, the elements are arranged in order of increasing atomic number, which usually matches the order of increasing atomic mass.
The periodic table is arranged in periods and groups. It has 18 main vertical columns called groups and 7 main horizontal rows called periods. This arrangement places elements with similar properties in the same column. The atomic numbers are usually noted above the symbols of the elements. Average atomic masses appear below each symbol. There are 2 general trends in the periodic table. Going down any group, the atoms get larger. Going from left to right across any period, the atoms get smaller. Down larger, right smaller.
Some atoms of an element have different numbers of neutrons in the nucleus than you're led to expect by the periodic table. Such atoms are called isotopes. Take carbon, for example. On the left is carbon with the mass number 12. Using that nifty notation, we can tell that the carbon atom on the left has 6 protons and 6 neutrons, since the atomic number on the bottom tells us that the carbon has 6 protons, and the mass number on the top tells us it has a total of 12 protons plus neutrons. Subtract the number of protons from the mass number, and you will know how many neutrons are in the atom's nucleus. In this case, there are 6. The carbon isotope on the right also has 6 protons, of course, but since the mass number is 14, we know that there must be 8 neutrons in this atom's nucleus instead of just 6. So carbon-14 is a carbon isotope.
Atomic masses are measured in atomic mass units called AMUs. See, we measure atomic mass with AMUs, so we'll have a standard of reference. Some ancient colleagues of mine decided to make carbon-12 the standard, so they assigned carbon-12 a mass of 12 AMUs. That means that an AMU has a mass equal to 1/12 of a carbon-12 atom. See, measuring the mass of atoms with AMUs keeps the measurement darn close to the mass number, which is 8. So all masses measured in AMUs are relative to the mass of carbon-12.
It's like referencing the distance of Chicago, New York, and Los Angeles by their distance from Washington, D.C. Washington, D.C. is the standard reference point, and the other cities are measured from that point.
So carbon-12 is the standard reference point for the mass of atoms, and the masses of all atoms are measured from the standard set by carbon-12.
Warning: beware of hazardous terms. AMUs are sometimes referred to as Daltons. If you see the term Dalton, don't panic. Handle the Dalton the same way you would handle an AMU.
At this point, you should be able to generate a full and appropriate response to today's essential question: what is the difference between atomic mass and atomic number?